This is Elena Moore, and I'm going to be discussing synapses and crossing over when given two chromosome pairs. So the first thing I'm given is MLI, centromere JKHG, and GHI, centromere JKLM. And we are also given that there is a crossing over event occurring between J and K. So what I did to make these as close as possible was I flipped the bottom chromosome because, as you can tell, the beginning and end would match. And I could still tell that the I, centromere J and K were inverse because there was an inversion event that occurred, which is why there's a loop there. So number 1 and number 3 was made to match the initial chromosomes, which is what we want. So the other two chromatid choices that we came up with are not viable choices because, as you can tell, they either are missing some parts of the chromosome or they are duplicating some parts. So those are not viable, so keep in mind that half of the chromatid choices are not viable in this situation. And then for the second one, we have MLI, centromere JKHG, and GHKJ, centromere ILM. So the only thing we had to do with this one was, you can't really tell when I flip it, but you can tell when I do the chromatid choices, was flip the whole bottom section, and you can tell when you write it backwards that it would end up being the same thing. So you can tell that in number 1 and number 3. And also, number 2 and number 4 are also the same as number 1 and number 3 because there was just a crossing over and these are the same chromosomes. So this means that they are all viable. And when discussing the fitness comparison, you can tell that the bottom is more fit because all of the chromatid choices are possible versus half. And that makes sense because there's an inversion event at the top one and there's only a flip in the second one.